Hi, welcome everyone. In this session, we will discuss on resource management. One of the most critical roles of an operating system is resource management. If you think of a computer as a busy city, the operating system acts as the city manager. There are limited resources, such as CPU time, memory space, storage, and I/O devices, and many processes or programs competing for them. Without a manager, you would have chaos, with programs potentially overwriting each other's data or one program hogging the CPU indefinitely. As a resource allocator, the OS must manage these resources efficiently and fairly. We will explore 5 primary areas of management: process, memory, file system, mass storage, and I/O systems. First, let's discuss process management. It is important to distinguish between a program and a process. A program is a passive entity, like a file sitting on your disk, whereas a process is an active entity. It is a program in execution. For a process to do its job, it needs resources like CPU time, memory, files, and I/O devices. These resources are allocated when the process is created or while it is running. As a process manager, the operating system is responsible for creating and deleting both user and system processes. It also handles suspending and resuming processes, which allows the OS to pause a task and pick up exactly where it left off later. Furthermore, the OS manages process synchronization to prevent data conflicts, process communication so different processes can talk to each other, and deadlock handling to resolve traffic jams, where processes are stuck waiting for each other's resources. Next is memory management. Main memory, or RAM, is the workspace of the computer, consisting of a large array of bytes, each with its own address. For the CPU to execute a program, that program, or at least parts of it, must be in RAM. The operating system's job is to manage this workspace by keeping track of which parts of memory are currently being used and which process is using them. It also decides placement, determining which processes or data to move into memory when space becomes available, and handles the allocation and deallocation of memory space when a program requests or finishes with it. Now, let's move to file system management. Users need to store information permanently, but different physical media like hard drives and SSDs have different ways of storing bits. The OS provides a logical view of information storage by defining the file as a logical storage unit. The OS maps these logical files onto the physical medium. Its responsibilities include creating and deleting files and directories and providing primitives, which are the basic tools to manipulate files through commands like read, write, append, and rename. Additionally, the OS maps files to specific physical blocks on mass storage and manages backups on stable, non-volatile storage to protect against system failure. While the file system provides the logical view, mass storage management deals with the physical reality. Because main memory is volatile and too small to hold all data, secondary storage like HDDs and SSDs is used to hold programs until they are needed. The OS must manage this storage efficiently because system speed often depends on disk performance. Key responsibilities include free space management, storage allocation for new files, and disk scheduling to optimize the order in which data requests are serviced. Finally, we have I/O system management. A main purpose of an OS is to hide the complexities of specific hardware from the user. The I/O subsystem consists of a memory management component that handles buffering, caching, and spooling. It also includes a general device driver interface to provide a standard way for the OS to communicate with different hardware, along with specific drivers that know how to talk to individual devices like keyboards, monitors, or network cards. In summary, resource management is the core administrative function of the operating system. By managing processes, memory, files, mass storage, and I/O, the OS ensures that the computer's hardware is used effectively, reliably, and fairly. Thank you for your time. See you in the next session. Bye.